Right, for these types of problems, we need to use Q equals MC delta T twice, but the easier way to do it is to set them equal to each other. The big concept is that the heat loss is going to be equal to the heat gained. Remember that the Q value for when you lose heat is positive for exothermic, so what we have to do is do Q loss is equal to negative Q gained. And in reality, you don't necessarily have to memorize this or remember it. It is helpful though, just to help you with the sign of Q and reinforcing it. One of the sides of the equal sign just has to be negative. So we're gonna pretty much turn this into MC delta T equals negative MC delta T. MC delta T equals negative MC delta T. Right, where the Q lost in this case is going to be for iron, and the negative Q gain is going to be for water, because that's the iron's losing the heat and the water is gaining the heat. This problem is the one we were working on in class, and we're trying to find the final temperature of the system. So it's 50 grams of water at 10 Celsius, 50 grams of iron at 90 Celsius. Specific heat of iron is 0.45, and we know the specific heat of water is 4.184. So we're just going to plug in, and in both cases, we're going to try and solve for the final temperature. So we have 50 grams of iron times the specific heat of iron, which is 0.45. Now for the delta T here, we want to do TF minus TI like we talked about. We don't know the TF, that's what we're trying to find. The initial temperature of the iron was 90, right? We do the same thing for water over here. You're going to have 50 grams times 4.184 times, we're going to do TF minus the initial temperature of water was 10. And I forgot to put the negative in here, which is really important. If you don't put the negative in here, you will get the wrong answer. So please don't forget the negative, right? Carry it through from here to here to here. And now it's plug and chug time. We're going to try and simplify both sides of the equal sign and then solve for TF. And this is where like all the algebra comes in. That is somewhat annoying. So 50 times 0.45 is 22.5. So we could say 22.5 TF times 90 minus 2025. Is this simplified? And then on the other side, remember we have to carry this negative all the way through. So you get 50 times 4.184. So we're going to end up with, it's going to be positive 2092. And 50 times 4.184. And it's going to be negative 209.2 TF. So now we want to combine the TFs and the constants. So we're going to add 2025 to each side. We're going to add 209.2 TF to each side. And that way both sides will come out positive, and we won't end up with a negative final temperature value. So we're going to get 4117 on this side of the equal sign. And we're going to get 231.7 TF on this side of the equal sign. Divide by 231.7 TF, divide by 231.7 both sides. So 4117 divided by 231.7. We should get a TF value of 17.76. 86664 degrees Celsius. So we're going to round that to just 2 sig figs because the numbers that we were provided only had 2 sig figs, right? 10 Celsius, 90 Celsius, 18 degrees Celsius. And that's it. So use the same method here to calculate, I think it's number 1 on your take-home quiz. Remember, it's Q loss is equal to negative Q gain. One of the equal signs has to be negative, and you're solving for TF in these cases because remember, delta T, like we talked about, is equal to TF minus TI is really what's being emphasized here. All right, thanks for watching. See you.